In this video, we are going to be exploring angles in a circle. Now, to get the best out of this video, I want you to pause the videos at certain points when I tell you to pause and really think about what's happening. We're going to be looking at pictures and things that are true and things that aren't, and I want you to look at those pictures and try and figure out why it's true or why it's not. And not to wait for me and just let the video flow and see why it is or why it isn't. So I really want you to pause when I tell you to pause and think about certain aspects. So let's look at our first exploratory here. It says Mr. Foti has a secret about the angles that are the same in a circle. Can you figure it out using the words that we've already learned? So using definitions we already learned, I want you to see if you can figure out what my secret is here. So first of all, on this side, over here, we have where x is equal to y. And my examples that will be on this side, on the other side, it's when x is not equal to y. So let's take a look at my first example. I'm going to pull it out here, and in this case, angle y is equal to angle x. I want you to take very close, pay very close attention to this circle and try and think of why. Now here is another circle, and we have angle y and x. Now I want you to pay very close attention to this circle and try and figure out why. Okay, let's look at my next few examples here. So you might have an idea why. Let's look at this one here. I have angle x and angle y, and these two angles are the same. Over here, I have angle x and angle y. Now, angle y and angle x are not the same. Let's take a look at one more. Over here, I have angle x and angle y. They are the same. Over here, I have angle y and angle x, and they are not the same. So I want you to pause the video right now. You could go back and look at these three examples I have here and try and figure out what my secret rule is for when it comes to angles being the same in a circle. So our rule here is twofold. So if we have two angles, we know they are the same if, one, they are subtended by the same arc of the circle, and two, they share the same feet of the circle. They need to have both of those properties in order to be identical or congruent. So let's look at why these ones aren't. These ones here, they have one of the property as they share the same feet, but they are not subtended by the same arcs, as one's using the major arc and the other one's using the minor arc to subtend them. So that is why this one here, this third one, doesn't work. The second one, well, I look at it, look at my feet. My feet match outside of the circle. So these ones don't work as well. Now I look at this one here, they're both subtended by the major arc, but if I look at this, they do not share the same feet again. And look at all these that work, they all have the same feet and they are subtended by the same arc. So right here, they're both subtended by the big arc and they share the same feet. This one right here, they're subtended by the minor arc and they share the same feet. So now we're about to enter the second exploration of today's video. In this one, Mr. Foti has a second secret about angles in a circle. Can you figure out what it is? Well, I look at this. On the one side, I know that x is double the value of angle y. So angle x is double angle y in the pictures on that side. On the other side, angle x is not double angle y with the pictures on that side. So I want you to see if you could think of what my rule is, but using certain key terms and definitions that we learned in the previous class. So here is my first picture. I want you to look at certain aspects of this picture. What kind of arcs, what kind of angles are these? What arcs are being used? Let's look at my next picture. Okay, let's look at my second one where it works. Once again, what kind of angles are those? Which arc? Let's look at my next picture. Let's look at another one where angle x is double angle y. So right here, angle x is double angle y. Let's look at another one where angle x is not double angle y. So here, angle x is not double angle y. Let's look at one more. In here, angle x is double angle y. And this final one, angle x is not double angle y. So now I want you to pause the video and write down what you think my secret is, but write down using certain key terms that we've learned before. So the rule you should have figured out is a central angle is double an inscribed angle if it follows two conditions. The first condition is if they both share, the inscribed and central angle, the same feet. The second condition is if both the inscribed and the central angle are subtended by the same arc. If both of those conditions are met, then the central angle will be double the value of the inscribed angle. So let's look at that here at some of these why they don't work. I look at this first one. My central angle is right here, and my inscribed angle is right there. If I look at this, for this to work, they are not subtended by the same arc. They share the same feet, but in order for this to work, this and this here would be the same arc. Let's look at this next one here. They share the same feet, but this is technically not an inscribed angle, as all feet must be on the edge of the circle. If we look at their second one that's wrong, yes, they do share the same feet, the inscribed and central angle, but if I look at this, the feet are not on my circle, or the circumference of the circle. So this one does not work. They're not completely inscribed. Now, if I look at the next one, well, I do have an inscribed angle, but my blue one here is not a central angle or an inscribed angle. So this one here does not work as well. Now let's look at our first example here. It says, determine the measure of the angle x and y. Well, if I look at this, let's first try and figure out what kind of angles we're looking at. If I look right here, my known angle is an inscribed angle. Angle x is also an inscribed angle, and they share the same feet. So knowing that, if they share the same feet, they're both inscribed angles, and they're subtended by the same arc, that means angle x must equal to 55 degrees. Now, let's look at my next one. We know angle x and we know angle c, which are both 55 degrees. But now angle y, if I look at this, this is an central angle, where we have my center, the orthocenter is there. So in this case, we have a central angle sharing the same feet with an inscribed angle. And they are both subtended by the same arc. So in this case, angle y is going to be equal to double angle x, or double 55, which is 110 degrees. So in this diagram here, we have a whole bunch of angles, and we want to try and solve for x, y, and z. Now the first thing I'm going to look at is try and figure out where are my central angles and what are my inscribed angles. So right here, I look at this 140. This is a central angle. Now the inscribed angle that relates and has the same feet is up here. So then I know that this angle here is actually going to be 70. But so far, we don't really need to know that angle. I look at angle 100. Angle 100 is also an central angle. And I look at this here. This is the inscribed angle that shares the same feet and the same arc. And this angle here then would have to be 50. So let's write those down. We have this angle here is 70. I have this whole angle here is 50. Okay, now remember, we know a whole circle is equal to 360. So if I continue this here, we have this section is equal to 360 minus 100 minus 140, which is going to end up giving me a total of 120. So now I know x is equal to 120 degrees. So we look at x. X is a central angle. And now, do we know any other angle that shares the same feet with it? Yes, we do. We have y, which is an inscribed angle that shares the same feet as that central angle. So y is going to have to be half the value of x. So now y is equal to x divided by 2, which is equal to 60 degrees. So let's put this in at 60. Now, I look at this here. I have two radiuses. I have a radius here and a radius here. This is going to be an isosceles triangle. I know this value of x, we said, is 120. And triangles add up to 180. So my z is going to be, so because we're looking at an isosceles triangle, I'm going to have 180 minus 120 degrees is equal to 2z. Because this angle here, this must equal to z as well. So z is going to be the same as those since we're an isosceles triangle. Now I look at that, we're going to solve for z. I just divide both sides by 2. I'm going to end up getting 180 minus 120 is going to be 60 degrees divided by 2 is 30 degrees is equal to z. So now we have all three of my angles discovered. So let's look at our last example of the day. In this one here, we have distances, but we're actually needing to use our angle circle properties to help us with these distances. So in this one, we have rectangle ABCD has its vertices on the circle with a radius of 8.5 centimeters. So I'm going to write down what we know. We know this here is 8.5 centimeters. We also know the width of the rectangle is 10 centimeters. I'm going to write this down, 10 centimeters. What is the length to the nearest tenth? I'm trying to figure out this side here. Now this looks very confusing. How do we figure this out? Well, first thing I'm going to do is continue and draw another radius here to make a diameter. This is 8.5 meters. Now I know that this angle here is, because it's a diameter, it's going to be 180 degrees. If this line here is 180, that could be a central angle. And we also have an inscribed angle over here, and they are sharing the same feet. So if we have an inscribed and central angle, I know the inscribed angle is going to be half. That means that angle there is going to be 90 degrees. This angle is going to be 90. And now that that's 90 degrees, I have a right angle triangle. So that means I could use my Pythagorean theorem, where we know c squared is equal to a squared plus b squared. So my hypotenuse is obviously this line right here, which is going to be my diameter of the circle. And that is a total of 17 squared. So I'm going to have 17 squared plus 10 squared. Okay, now what is 17 squared? If you remember from before, you should have these memorized by now, is 289. And 10 squared is 100. Alright, so now we add this up together. I'm going to get 389, and we're going to square root that to get c. I know 19 squared is equal to 361. And I know 20 is equal to 400. Now 389, altogether, we have a difference of 39. And that is going to be, I look at 389, it's somewhere over here. And that's going to be 28 away. So it's 28 out of 39. So that's almost like saying 3/4 of the way. So I'm going to end up saying C is equal to 19.6 or 19.7. And we want centimeters.